Hi, Ken. Nice to see you.
Hi, Adam. Nice to be here.
Let's take a seat.
Certainly.
Hello, I'm Dr. Adam Watson, and today I'm here at Umbrella to talk about one of the most crucial aspects of quality control, which is the process that produces a certificate of analysis, or COA. Here at Umbrella, we pride ourselves on always doing testing of SARMs and peptides every batch possible in order to produce a COA to ensure the highest level quality of all research products. In order to maintain strict quality control, Umbrella Labs has teamed up with MZ BioLabs, which is another local Arizona-based company, in order to provide ongoing quality control testing for all of our research products. Today, we're sitting down with Ken Pendarvis, who is the lead chemist at MZ BioLabs. And if you're already a customer of Umbrella Labs, you'll recognize his name because it appears on every single COA that we produce. Ken, thanks for being here today.
It's my pleasure.
First off, could you tell us a little bit about your background, your academic background, and then how long you've been working with MZ BioLabs?
My background is in chemical engineering. My interest and sort of specialization was in fluidics. And HPLC is basically microfluidics, and I found it very interesting, and that's the field I've been working in for the last 20 years.
So did you ever have much interest in the sort of academic side of it, or were you always more interested in sort of the industrial side of it?
Well, kind of both. So I started out in academia. My first job was running HPLCs and mass specs at Mississippi State University in their proteomics lab. So we were testing peptides on a massive scale, but not just single peptides like we do for purity testing. These were mixtures of hundreds of thousands of peptides generated from tissue samples or bacterial samples.
So you've seen sort of both sides of both the academic and the industrial side of quality control.
Yes.
And so tell us, how long have you been working with MZ BioLabs, and how long has the company actually existed?
Okay, so I started MZ BioLabs with my business partner, Nino Asana, about 5 years ago.
So you're one of the co-founders?
Yes.
Oh, excellent. So about 5 years now. And can you tell us did you start off really small with a couple clients here and there, and then how much has it grown in the last 5 years? How many clients and labs do you actually test for now?
Well, actually, Umbrella Labs was our very first customer.
Oh, wow.
About 5 years ago. You had several compounds and you needed a C of A, and I said, yeah, I can do that, and here we are.
Wow, so coming from being the very first and all the way through till now, and how many different clients and customers do you have now? I'm sure you've expanded a lot.
Oh yes, we have several hundred clients from all over the world, the US, Europe, Australia, Asia.
Wow. So in terms of the number of different testing modalities and instruments you have, can you kind of walk us through a general overview of the different types of testing and the machines they require?
Okay, so the base testing that MZ BioLabs does is HPLC with UV detection. That is the kind of the go-to methodology.
Like the workhorse that you guys use.
For doing purity testing. What we do that kind of makes our analysis specialized is we add mass spec to the end of that. So you get, for every sample, we get HPLC for testing purity, and we get a mass spectrum generated, which lets us positively identify the compounds at the same time.
Interesting. So in terms of the HPLC, that's the workhorse of the purity analysis, what is the actual sort of brand of equipment that you guys use? And what sort of features do your instruments in particular have that might be better than some other instrumentation that's out there?
So our HPLC equipment is exclusively Waters Acuity HPLC systems now. Okay. These are they're newer. They're referred to UPLC, which is ultra performance HPLC.
I see.
So they operate under very, very high pressures, up to 1,000 bar, or I think 14,000 psi. This lets us use very small HPLC columns, as opposed to the standard ones, which are 4.6 millimeters in diameter. We use columns that are 2.1 millimeters in diameter. This lets us do the same separation in less time, at a higher flow rate, to get better resolution.
Now, in terms of the actual time it takes to do a run, Sort of is this on the order of minutes or hours? How long does it take to generally do a run on HPLC?
Using these current HPLCs, our runs typically are 12 or 14 minutes. This is down from 30 minutes just a couple years ago. So by improving our instrumentation, we've actually doubled our throughput.
So I was hoping you could walk us through an example. We have one here, a COA of RAD 140, and I just wanted you to walk us through some of the important features that customers can see on the actual COA itself.
Oh, certainly. So we have, the first thing I look at on a COA, and probably the most important thing, is what is the purity, because that's the point. For a pharmaceutical grade compound, you want a purity that is above 99%.
Right.
Anything lower is considered just kind of raw, unpure.
Non-research grade.
Non-research grade, correct. We list a methodology. For everything, we use mass spectrometry and UV, if applicable. And the second most important part here is the chromatogram. This is a visual representation of your sample as it goes through the UV detector. So there's a baseline, there's the main compound, and if any impurities are there, they show up as tiny little blips. So it's kind of hard to see, which is good. We want it to be hard to see. Yeah. There's a second compound that is right here, which makes up 0.24% of the total. So if you do the math, that ends up being 99.76% purity, which is excellent.
Right. And so, and just to point out, of course, 100% purity would be, theoretically ideal, but as people that are in, chemical engineering know, that's actually not practically possible for a lot of reasons that have to do with the supply chain, right?
Yes, it's not practical. We do rarely see compounds that are so close to 100% pure. The software,
it rounds up.
It rounds up to 100.
Okay.
But in actuality, nothing is completely pure.
Yeah.
And from the moment a compound is produced, there are environmental factors that start degrading it.
Right. Even from the air and
even
whatnot.
from the air, moisture from the air, oxygen from the air.
Right.
Some compounds are just unstable.
So does this mean, like, basically if the point that there is always going to be a little bit of noise in the system, that actually tells you that this is a genuine COA?
Yes. And yeah, if you see something that's just too clean and too perfect, it's probably faked or altered in some way.
Right.
Nothing's perfect. You're always going to see little up and down blips at the start of the chromatogram. You're going to see some at the end where the conditions return to normal.
Just some natural variation.
Yes, you need to see fluctuations. But what is important for our purity testing is what's going on in the middle.
Right.
This is where we try to adjust parameters to get our compound between a good balance of separation and sensitivity.
Excellent. Thank you so much.
Yes.
So we're really excited that we've been able to team up with MZ BioLabs to start adding some new elements to the COAs as we start rolling these out wherever we can. And so I wanted to go over one of our brand new COAs. So here's tirzepatide. Now this one's actually 2 pages now. And the reason being, there's the HPLC chromatograph on the first page and then the mass spec on the second. So I was wondering if you could walk us through, like, how are the different spectrographs here different? Do they tell us different things? And why is it important to have these 2 different kinds of graphs?
We've modified our COA format in the last few days to be more descriptive and transparent at the same time. So you can see we've got 2 pages now. The first page is HPLC, and we've given a description of the test. So it's high performance liquid chromatography, which is for purity and quantity. So quantity or volume is something we've recently started adding for peptides as we are able to do so. This lets you get a measurement of the actual dosage in the vial, so you're not being underdosed or overdosed. So if you buy 15 milligrams of tirzepatide in this case, you can be sure that you're getting 15 milligrams. And we label it here, and we use HPLC with UV methodologies to do that.
Certainly really important to know, how much is actually in the vial, because for lyophilized peptides, it's very difficult, if not impossible, to even visually try to guess, right?
Yes.
Because a lot of a lyophilized peptide, it's very light and airy. It's impossible to really know visually.
Yes, looking at the vials, that is in no way representative of the amount in there.
Right.
If they added a dilute solution before lyophilization, it's going to be thick.
Right.
If they added a concentrated solution, it's going to be thin, and it has nothing to do with the amount of peptide.
So it seems like it's really crucial to be able to know, whether or not there's actually, the accurate amount in that vial.
Yes. Our second page is new, and it used to be represented on the original C of A's just by a few lines that said the molecular weight that is expected for a compound, and here's what we measured. So that's still there, but we've included the actual mass spectrum that MZ Bio uses to interpret the data. So you see what we see. This is what I use to identify, in this case, terzepatide. We do a little math, and we calculate the measured mass, compare it to the expected mass or molecular weight, and we confirm the identity.
So this essentially adds another layer of transparency. You'd essentially, use this information here to even audit the actual COA itself to make the calculations yourself. So really, it's adding a lot more transparency for the customers.
Yes, I've seen fake COAs that use a spectrum because they don't have knowledge of mass spectrometry. They use the incorrect spectrum from a different compound.
So it doesn't even line up.
And
with
it doesn't
the numbers.
even line up. So we put this as transparent. We'll have links on our website for educational resources. So if you want to learn how to interpret this and check my work, feel free to.
That sounds like a fantastic new improvement.
Yes, yeah,
Awesome.
we're excited.
So one thing I want to ask you about as well, a lot of people generally have questions when it comes to heavy metals, for instance. So do you use a different kind of modality for heavy metal testing?
Yes, so heavy metals are largely invisible to UV and mass spec. What we use for heavy metals, not at MZ BioLabs, we don't do heavy metal testing, but you use what's called ICP EOS. ICP is inductively coupled plasma, which is an ionization technique that it uses electric fields to get metals airborne, and EOS is emissions.
Is it electrospray or?
It's kind of like electrospray, yes. So it's sprayed in through a nozzle through a high temperature electric field.
Okay.
And it just ionizes. I don't know if you remember back in chemistry where you did the little flame.
Right.
And you dip it in copper and the flame would be blue.
Right,
or
the
you
flame
dip
color.
it in chromium and it would be a different color.
Right.
So this is actually the same technology.
I see.
The OES instrument on the end actually measures the color of the flame as those metals are ionized. The other option is ICP-MS, which is ICP with mass spec, which uses the actual molecular weight of the elements to identify them. Both are equally accurate. The only difference is basically a price point.
So one thing to point out is that generally heavy metals are not an issue for synthetic compounds, right, like SARMs or peptides that are built from scratch. This is typically something that comes from sort of more natural products, right?
Yes, yes. We get feedback occasionally. I can't think of any instances where a SARM or nootropic or peptide actually had heavy metal contamination. Where heavy metals are an issue are in plant extracts. Plants have the innate ability to pull minerals from their environment and incorporate it into their leaves and stems. That's where heavy metals can pose a problem.
I see. So in terms of, you talked a little bit about the different types of modalities. I'm sure there's older instrumentation out there, some newer instrumentation like the QT system. What are some of the improvements, the technological improvements that you see sort of on the horizon? Or are the databases expanding? What allows sort of increasing resolution and increasing accuracy of sort of quality control testing?
The first is comprehensiveness and availability of databases. The databases let us identify mass spectra, such as the one in this C of A here. If I don't know what it is, I can search it against a database and possibly get a positive ID, and then I can tell you, yeah, this isn't terzepatide, it's actually this other compound.
I see.
So I can, with a database, I can give it a name and an identity as opposed to unknown.
And so I guess as these databases expand and these reference spectra become more available to you, this allows greater and greater ability to detect even slightly different compounds, right? Compounds that might have very similar spectra, but they're different enough that now you can determine the difference because of these larger databases.
Yes, and this is where new advancements in mass spectrometry also play an important role. So if your mass spec has very low resolution, such as some of the older type instruments from the 90s or early 2000s, it wouldn't matter how good your database is, if the compounds are too similar, the mass spec can't distinguish them enough to get a positive ID.
I see.
Newer mass specs have vastly improved resolution. And what resolution means in mass spectrometry is it's to be able to tell the difference in peaks that are very close together. So if you have one peak...
So you can zoom in, essentially. The more you can zoom in.
Yes. Yeah. So if we zoom in on this, a low resolution instrument might just show one peak. High resolution instruments, if you zoom in far enough, you might see 3 peaks, and you go, hey, there's something going on here. It's not just my compound, there's 3 compounds here.
And that could be, vastly influential for the end user, the experiment in the end, right?
It is, yes, and I do see this from time to time. Actually, the last case was with terzepatide, where I zoomed in, actually found that there were 2 peaks overlapping in the mass spectrum, and one was shifted just a little bit, which means the terzepatide molecule was not formed perfectly. A certain percentage of it was not technically terzepatide.
So what you're saying is, in the case that if it was another company, offering that terzepatide batch, that no one would know, right? I mean, the customer might actually have that batch then, and because they're not using, they might not use any testing, but even if they're using testing, but it's old methodology, they're not getting what they think they're getting.
Correct, yes. If your technology is not good enough to distinguish different compounds that are that close together, you don't know what you're getting.
So that's obviously the worst case scenario when there's no testing done, and we both know, unfortunately, there's lots of companies out there selling research compounds that they don't do any testing whatsoever. But let's talk about the companies, other companies. They might do testing, but they might not really be, real, genuine quality control testing. So, what are some features of COAs that might tip you off that this is not a legitimate COA? So what should customers be looking at? We talked about all the good things that we have on our COAs, but what would tip you off that a particular COA from a different company might not be genuine?
The first type of COA that comes to mind when questioning the legitimacy are the ones with no graphical representations, no mass spectra, no chromatograms, just a few words that say BPC 157, purity 98%, color white.
Odor none.
Odor none.
Okay.
That's not very applicable. That applies to almost everything imaginable.
Right. So essentially no raw data at all.
No raw data
Just
at all.
a sort of supposed interpretation.
Yes. So if you see those, I don't trust that in any way. I would pass or have some additional testing done.
So that brings me up to my next question. Should researchers even bother, ordering and experimenting with research compounds that do not have COAs?
I wouldn't touch anything that didn't have a COA because you don't know what you're getting. I've been doing this testing for a while, and about 20% of the compounds we test are mislabeled or downright fake.
Wow, that's shocking.
As in sugar or
Right.
salt.
So not only could customers be paying for, again, sugar, in some cases it could be actually quite dangerous to be doing research with compounds that are not properly identified or not pure enough.
Yes, we frequently see mislabeled compounds, and we've seen SARMs that were labeled as nootropics. We've seen enclomiphene that was labeled as a SARM. I mean,
so just all over the board.
All over the board.
Well, it's really good that that we have you do the testing. It seems like it's just could be a potential nightmare out there without actually having quality control. Certainly, as long as I've been involved in this industry, I never cease to be amazed by some of the stuff that goes on out there in the industry. So it's really good that we continue to work together and keep the bar really high. We're certainly really happy to have Ken's expertise. It's really cool to find out that UmbrellaLabs was actually the first client of MZ BioLabs 5 years ago, and we still continue to have a great relationship and continue to do batch by batch testing of every SARM and research peptide in order to ensure the best possible research is done in the end. Big thanks to Ken again for coming in today. And if you want to learn more about our COAs, please head over to the website and click through, and you can see all the actual granular detail yourself. You can learn a little bit more about what goes into a COA, all the important features. And again, Thanks for watching. We'll see you next time.